in this problem we're given a function f and we are to find all of its zeros. So what that means is we're trying to find x values that make the output f of x equal to 0. So setting f of x equal to 0 would look like this, and I'm hoping to get as many of the solutions that I can from graphing this function on the real plane. Now since this is a polynomial of degree 3, we are expecting to get 3 solutions. But just because there's 3 solutions does not mean that all 3 solutions will show up when graphing the function on the real plane, because it's possible that 2 of the 3 solutions are not real. So 2 possibilities exist. Of my 3 solutions, we could get 3 real solutions, or since non-real solutions come in pairs, we could get 1 real solution and 2 non-real solutions. So let's just go to the graphing calculator and see if we can get any of the answers for free, so to speak, by pressing y equals and type in our function, making sure to use the subtract key instead of the negative key in this context. To see if there's any real solutions between negative 10 and 10 on the x-axis, I'm going to press zoom 6 to graph in a standard window, and I'm looking for where the graph may cross the x-axis. In the standard window, each tick mark is 1 unit. So counting the tick marks, I see 1, 2, 3, 4. It looks like around x equals 4, we may have a 0 of the function. To verify this, I'm going to evaluate the function at 4 by pressing trace, and then typing 4, enter, and notice the calculator is telling me that when you plug 4 into the function, we get out y equals 0. This defines x equals 4 to be one of the solutions to this equation, which makes it a 0. So x equals 4 is one of the zeros of the function. If you know what the graph of the cubic looks like, it looks like we're seeing the full behavior of the cubic. On the graph, I'm seeing a definite relative max and a relative min, so I'm not expecting this curve to the left or to the right to eventually curve back and hit the x-axis again. So I'm guessing at this point that the other 2 solutions are not real and will not show up when graphing on the real plane. So what I'm going to do is use my solution of x equals 4 to argue that that means that x minus 4 would have to be one of the factors of this function. To find the other factor, I'll have to perform polynomial division. So if my function can be written as x minus 4 times some other quadratic, I can determine what that quadratic would be by simply dividing the given polynomial by the factor x minus 4. Much like if you knew the number 12 can be written as 3 times some number, you could figure out that number by dividing the 3 over. So to be clear, we're saying that this cubic expression can be written as x minus 4 times some quadratic. And our job is to take that idea and find that quadratic by simply dividing the x minus 4 factor on both sides of this equation. After all, it is a factor, which means it's currently being multiplied. So to solve for the question mark, so to speak, the quadratic expression I'm looking for, we can divide over the x minus 4, and I can figure out what that other factor is going to be. So let's do polynomial division to perform this division right here. So we're taking this cubic polynomial and we're dividing it by the factor x minus 4. So how this plays out is we need to put an expression here so that when multiplied by x minus 4, the first term would give us x cubed. So if I put an x squared here, when you go to multiply x squared by x minus 4, you'll see that you'll get an x cubed, which lines up nicely with this. And we also get a minus 4x squared. And then the process involves now subtracting that. So we have x cubed subtract x cubed. That would be 0. And then you have negative 4x squared subtract a negative 4x squared, which makes negative 4x squared plus 4x squared, which is also 0. So the next thing to do in the process would be to bring down the next term, x. But I notice in this special case that this matches what I'm dividing by. So in this case, I'm also going to bring down the subtract 4 here and simply say now that if we multiply by 1 times the factor x minus 4 will be x minus 4. Then when we subtract in the process now, you'll get 0 as a remainder. So the idea is, to summarize, we took the cubic polynomial, we divided by the factor x minus 4, and we knew that would be one of its factors because remember x equals 4 was a 0 of the function, and the result that we got was x squared plus 1. So what that means is, if I was to multiply both sides by x minus 4, what I would get is that our given cubic polynomial could be written as x squared plus 1 multiplied by x minus 4. So in a sense, I've factored the cubic polynomial into a quadratic times a linear factor. So if you go back up here, where I previously had a question mark, we now figured out that that is x squared plus 1. Now remember the context of this, of course, now that we've factored it out, is we're wanting that cubic polynomial to be 0. We're finding the zeros of the polynomial. So by the zero product property, which says if you have a product that gives you 0, then the solutions can be found by setting the factors equal to 0 and solving. We already have the solution x equals 4. We got that from the graph. Now to get the solution to the equation x squared plus 1 equals 0, you could use the quadratic formula, but in this particular case it would be much easier just to subtract the 1 on both sides to get x squared as negative 1, and then find the two solutions to that quadratic by taking the square root of both sides. When you do the principal root of the right hand side, you'd get the square root of negative 1, and then the other solution would be the negative root, which is negative square root of negative 1. And when you see the square root of negative 1, we commonly use the letter I to represent it. So I'm going to get x equals I and x equals minus I is my other two zeros. Now you could check your solutions by plugging in x equals 4, x equals I, and x equals negative I into the original polynomial. I plan at the end of the video to choose one of these, say x equals I, and I'll show that you do end up getting out 0 for an output. But first I want to point out that now that we know that I and minus I are solutions to the quadratic equation x squared plus 1 equals 0, we could now complete our factorization. All polynomials can be written as the product of linear factors. This was not a linear factor, it was a quadratic. So knowing that x equals I is a solution, we will take that solution x equals I and say one of the factors must be x minus I, much like we'd said that if x equals 4 is a solution, then x minus 4 would be a factor. And then our other solution of x equals negative I means that x plus I would be a factor. So what you see here is I have a cubic polynomial being expressed as the product of three linear factors. If this looks foreign to you, it may be a good exercise to actually multiply out these three factors to show that it is indeed equivalent to the given polynomial in this problem. Doing so is just quick enough that I'm going to do that here. So if you take these three factors, I'm going to copy the x minus 4. I'm going to multiply the factors x minus I and x plus I. This multiplication gives you x squared. This multiplication would give you I times x. This multiplication here would give you negative ix. And then finally, negative I times positive I gives you negative I squared. Now notice that ix and minus ix simplify down to be addition of 0. And copy the x squared. And then minus I squared is minus, now remember I squared is the equivalent of negative 1. So all I did there was replace I squared with the number negative 1. And now you see that this is x squared plus 1. And if you let me multiply these two factors now, you'd get that x times x squared is x cubed. You get that x times 1 would be just plus x. You'd get negative 4 times x squared, which is minus 4x squared. And finally, negative 4 times 1 is minus 4. Putting this in descending order, you get x cubed minus 4x squared plus x minus 4. So what I've done here is I've multiplied out these three linear factors, and what I obtained is the polynomial given in the original problem. To make sure, let me make a copy of that, in fact, and move it up to the beginning of the problem to verify that that's actually true. Yes, by multiplying out the three factors, we do end up getting back the original polynomial. So the only thing left to do now is I promised at the end of the video that I would show that x equals I was indeed a 0 of the function by replacing x with I and show that the output would be 0. So doing that, if you let me replace all of the input variables with I, we would get f of I equals I cubed minus 4 times I squared plus I subtract 4. I cubed is equivalent to negative I. This gives you minus 4i squared. Notice that minus I and plus I simplify out. Also remember that I squared is negative 1. So what we have left here is minus 4 times the I squared. I'm going to replace as a negative 1. And then I copy the minus 4 here. So what I get is positive 4 subtract 4, which ends up being 0. So in summary, I plugged I into the function and I got out 0. That defines x equals I to be a 0 of the function. And you could also do this with x equals negative I, which was the other non-real solution that we got, and you'd see that that is a 0 as well. Thanks for watching the video.